Hello everyone, my dear students, good morning and hope everybody is safe at home and please take care about your health as well as your parents and don't show any negligence in this pandemic condition and all the best for your next session and please be serious about our new session and don't take it easily and we can listen later on. Don't do that one. Please follow regularly. All the best and come to our next chapter, Redox Reactions. So what exactly redox reaction? I written here. Redox reaction means the reaction in which both oxidation and reduction takes place. That is called redox reaction. I repeat, the reaction in which both oxidation and reduction takes place is called redox reaction. And what exactly here, what oxidation and reduction we have? Definitely one question for us. So I will give you clearly what is oxidation and what is reduction now. Oxidation means loss of electron or else addition of oxygen. Addition of what? Oxygen. Or else removal of hydrogen. So this is about oxidation. Sir, on paper how to identify oxidation? Means we can identify during oxidation state increases. Oxidation state what happens? Increases. Oxidation means increase. Okay, so during what happened? Means what? Loss. Okay, right, omitting. Means loss. So loss of electron here. So oxidation means loss of electron. Okay, during oxidation what happened? Oxidation state what happened? Increases. Okay, or else you can identify number of oxygens in reactant side and product side. If for a particular particular atom, if number of oxygens in reactant sides 2 and in product sides 3 or 4, something like that, more than 2 if you have, you can say for that particular atom oxidation happened. Getting what I am saying? So oxidation means you can identify by calculation of oxidation state. Okay. So once if you calculate oxidation state of an atom in reactant side and product side, some X atom oxidation state you have in reactant side +2, the same X atom oxidation state you have in product side +4, that means X atom oxidation state increased from +2 to +4. So X atom undergone oxidation, you can say. Okay, so oxidation state increase or else number of oxygens with that particular atom increases from reactants to products. That is also called oxidation. Or else removal of hydrogen means number of hydrogens removing or decreasing. That also we can call it as oxidation. If you understand what exactly oxidation, you can say what is the reduction. It's very simple. Now exactly reverse. Here loss of electron I said. So here gain of electron. Gain of electron is reduction. Or else you can say removal of oxygen, you can say, or else addition of hydrogen. Addition of what? Hydrogen, you can say. This is what? Reduction. So during reduction what happened? Here oxidation state decreases, oxidation state reduce, or else oxidation state reduce. Oxidation state of a particular atom will reduce. Reduce means reduction. See, R and R. Oxidation state what happened? Reduced, means decreased in oxidation state. Some Y atom in reactant side you have a +4 and in product side it became +2. Means for Y atom oxidation state changed from +4 to +2. That means what you can say? Oxidation state of a particular atom decreased. So here I think you have one clarity. What is that? to identify oxidation and reduction, whether oxidation happened or reduction happened. What exactly important thing here means oxidation state or oxidation number. So here also oxidation state of atom, how changed from reactants to products. If you know, you can say whether oxidation happened or reduction happened. Clear? Okay. So this is about oxidation and reduction. Please have a screenshot. So, and one more important thing, it is not our regular class. So seriously I'll explain. Okay. So you have to listen carefully without feeling bored and have a screenshot about what is redox reaction and what is oxidation and what is reduction. Thank you. And now I will give you the very much important thing, that is how to calculate oxidation state. So to understand that how to calculate oxidation state, you must know some rules. Okay. So here our next topic, calculation of oxidation state. So we will follow some rules for that. What are the rules? Very simple. We will fix oxidation state for certain atoms and groups here. Okay, first one is for alkali metals. For alkali metals, oxidation state is always 1. That is +1, not -1. See, what is oxidation state? In periodic table also we learn. Oxidation state means formal charge of atom. Formal charge of atom or formal charge exists on atom due to loss of electron or gain of electron or else unequal sharing. So unequal sharing, because of that, oxidation state can be positive, oxidation state can be negative. Due to loss of electron, oxidation state will become plus. Due to loss of electron, plus charge will increase. Due to gain of electron, negative charge will increase. This is a very, very important thing. Or else, for more electronegative atom, oxidation state will be negative. For less electronegative atom, oxidation state is positive. Oxidation state can be 0 also. Oxidation state can be fractional also. This is very, very important. And one more thing, oxidation state exists only in combined state. Only in what state? Combined state. So oxidation state when exists means it's very clear. Oxidation state exists only in what state? Combined state. This is very, very important. So most important things I'll tell you here. Okay. For alkali metals, oxidation state is always +1. And the second one is for alkali metals means what is the meaning? 1A group elements. 1A group elements in periodic table, you know. What are those? Lithium, sodium, potassium, rubidium, cesium, francium. For all these, oxidation state is always +1. For alkaline earth metals. Alkaline earth metals. Do you know what are the alkaline earth metals? Alkaline earth metals means 2A group elements. For alkaline earth metals, oxidation state is always +2. Remember this. What are the alkaline earth metals? Means beryllium, magnesium, calcium, strontium, barium. Actually, for this francium we have no need to say because that is a radioactive element. Here also a radium. Okay, we have no need to take beryllium, magnesium, calcium, strontium, barium, radium. So, but for radioactive elements we won't give oxidation states, and of course their group number oxidation state only we will take, but here we won't take because the radioactive elements won't have any chemical reactions. Okay, sir. And the next thing is third point. When oxidation state exists, I said in combined state only. So oxidation state of atoms in their free state will be 0. Will be what? 0. This is the most important thing. So in elemental state we call that also. That also we call what? Elemental state of in elemental state for atom oxidation state we will consider 0. Remember this one. Elemental state means what, sir? Suppose Cl2. This is elemental state. H2, Cl2, O2, N2, Br2, I2, F2, whatever. For all these, oxidation state will be 0. What is the oxidation state for all these cases? Oxidation state we will consider as 0. Understanding, everyone? So it is an elemental state. Elemental state means existing state in nature. How hydrogen exists? Diatomic. Suppose S8 sulfur, S8 0, P4 oxidation state 0. Because these are the elemental state. What state? Elemental state. In elemental state, oxidation state will be 0. Remember this one. So when these have oxidation state, lithium have oxidation state if it is not combining with anybody? No. Only lithium? No oxidation state. Sir, suppose Cl2 I said oxidation state 0. But HCl in that H plus Cl minus. Here chlorine have oxidation state or not? Yes. But as Cl2, chlorine don't have any oxidation state. But in HCl, chlorine have oxidation state. To understand Y minus and Y plus, I told you already, more electronegative atom has negative oxidation state. Remember this one. And less electronegative atom has positive oxidation state. These two things you please remember. Everybody. More electronegative atom have negative oxidation state and less electronegative atom have positive oxidation state. I told you, do you remember or not, I was given one trick to have those electronegativities. Hydrogen electronegativity value I was given 2.1 and chlorine is 3. Like this I was given. So who is more electronegative? Chlorine is more electronegative. Certainly chlorine has minus charge and hydrogen has plus charge, like this. So how to know electronegativities? I was given one trick for you. So by using those electronegativity values, you can have who have positive oxidation state and who have negative oxidation state. When elements don't have oxidation state, in free state, elemental state means what is the meaning? Free state. What is the free state? Uncombined state. Remember this. And in combined state for alkali metals always +1. See, this I was given in periodic table also. Do you remember or not? Up to 4A group elements, group number is the oxidation state. From 5th A, it is group number -8. Please revise the oxidation state concept in periodic table once. Okay? And this I was given, and please note it down by having screenshot. Thank you. And next I'll give you few more points for understanding this oxidation state calculations. So when oxidation state exists, only in free state or combined state? Combined state only, not in free state. This is a very important thing. So how to calculate oxidation state? 3 points we discussed. Next, 4th point. How to calculate oxidation state? I said what points? First, oxidation state won't exist for elements who are in free state. Oxidation state exists in combined state. Oxidation state is possible for atoms when they combined with other atoms. How we decide positive or negative? Who lost electron? Positive. Who gain electron? They are having negative oxidation state. Are unequally sharing in covalent bond. I told polar covalent bond in chemical bonding. So less electronegative atom having positive and more electronegative atom has what? More electronegative atom has negative oxidation state, like that. Okay, next point. About hydrogen we have to talk. Hydrogen exhibit two oxidation states. How many oxidation states? Two oxidation states. One is the hydrogen can have a +1 and hydrogen can have -1. This is the most important thing. Hydrogen exhibit two oxidation states, that is one is +1 and another is -1. So when +1 oxidation state hydrogen exhibits means very simple, with the non-metals. With what, sir? Non-metals. With the non-metals hydrogen exhibits +1, and with metals hydrogen exhibit -1 oxidation state. But few things I'll give you here, like CH4 like this. Here carbon electronegativity value, if you see, it's 2.5 and hydrogen is 2.1. So that you can say hydrogen is +1. So 4 hydrogens +4 and carbon is -4, you can say. Like that. Generally I am telling you example. Even in NH3, if you see, nitrogen electronegativity is 3 and hydrogen electronegativity value is 2.1. Hydrogen 2.1, right? So who is more electronegative? Nitrogen. So hydrogen here +1 certainly. 3 hydrogens, so +3. And nitrogen, it is -3 like this. But in some cases like BH3 like that, if you see, boron electronegativity is 1.9. I was given like this, you remember or not? Lithium, beryllium, boron like this. Take one and increase by lithium, beryllium, boron and carbon I was given. And here I said 1, 1.5 and 2. Like this I was given. Sorry, it's 2. Almost like that. So 2. Increase by 0.5 I said. Increase by 0.5. Suddenly here hydrogen is 2.1. So hydrogen is more electronegative. So exceptional case here. Hydrogen has -1 and boron has positive charge here. 3 hydrogens now. So 3 into -1, -3. So because hydrogen I said either +1 or -1 I said. Clear? So 3 hydrogens are there. 3 into -1. So boron has +3. Because molecule overall oxidation state will be 0. Okay? That means sum of the oxidation states of all atoms in a molecule is always 0. Remember this one. That's why then how you set up +3 you may have a doubt. So hydrogen, each hydrogen is -1 here because electronegativity is more for hydrogen. Electronegativity is more for hydrogen. It's 2.1. It's more. So what I am saying here, the most important thing, sum, okay, sum of the oxidation states of all atoms, sum of the oxidation states of all atoms in neutral molecule. What molecule? Neutral. Neutral means, what is the meaning? Because there are no charge. In neutral molecule. Sum of the oxidation state of all atoms in neutral molecules is equal to 1. Sorry. Equal to 0. This is the most important thing. Please remember. Okay, sir. So here I said about hydrogen. Hydrogen exhibit two oxidation states. One is +1 and one is -1. So here I was given some examples, and I was not given -1 example with metal. So suppose NaH example, NaH. Here I am giving examples 1, 2, 3 and 4th example here. So here sodium is metal, no? So metal, it's 0, even electronegativity values, electronegativity of sodium is 0.9. Electronegativity of Mr. Hydrogen is 2.1. So it's more. So hydrogen is minus, sodium is plus. I was given in previous. Who have more electronegativity, that exhibit negative oxidation state. Who have less electronegativity, that exhibit positive oxidation state. So here from beginning, if you see, 4 points we discussed, and have a screenshot along with these examples, please. Okay, thank you. And I said sum of the oxidation states of all atoms in neutral molecule is equal to 0, I said. Understood, sir, everyone? Next, our fifth point is oxidation state of halogens. Oxidation state of halogens. What I have to say? Halogens means everybody have idea. Fluorine, chlorine, bromine, iodine, astatine. Astatine not required. So I have no need to say about this. I was given already oxidation state from 58 to 8A, I said. Do you remember or not? Group number -8. I was given this in periodic table. So halogens group, these are halogens. Halogens means 7th, right? So what is the general oxidation state of halogens? Tell me. General oxidation state of halogens is 7 minus 8. So -1. -1 is the general oxidation state of halogens, because halogen group number is 7. So you know the periodic table. So I have no need to say separately. And as we know, what is the fluorine oxidation state? Fluorine oxidation state is always -1. Why, sir, fluorine exhibit -1 only? So what is the reason behind it? Means, as of we know, fluorine is the highest electronegative atom. We know that fluorine electronegativity value is 4. Highest, most electronegative atom is fluorine. So it cannot exhibit positive. Okay. So actually, if you examples like OH minus and F plus, they will say that's the reason this is very much unstable. Fluorine can have positive only in this molecule HOF, hypofluorous acid. But except this, of course, that is unstable. Except that in remaining any molecules, fluorine have -1 oxidation state only. This is fixed. Please remember all these points, what I am saying. And remaining, as you know, as going down, oxidation state can be group number, I said. So remaining like chlorine, bromine, iodine can have positive oxidation states. You know this, correct? Sir, as going down, I said like fluorine, chlorine, bromine, iodine, as going down, group number oxidation state also possible, and group number -2 oxidation state also possible, and this is stable, I said, as going down due to inert pair effect. As going down, group number -2 is more stable, I said, oxidation states. So these all points are very, very important. Suppose HCl, as I said, chlorine is more electronegative here. Electronegativity values I was given. So hydrogen is plus and chlorine is minus. But Cl2O3 or Cl2O7 like that, if you see, chlorine have positive here. ClO2 or Cl2O3 or Cl2O4, Cl2O5 like that. Here Cl2O like that, if you say. And in all these cases, chlorine electronegativity 3 and oxygen electronegativity 3.5. So here oxygen -2 and chlorine is positive oxidation state +2, because actually 1 chlorine plus 1, 2 chlorines, no, like that. How to calculate, I will tell you. So 2 chlorines oxidation state is +2, 1 chlorine oxidation state is +1, 2 chlorines +2, because oxygen is -2 now. Okay, oxygen is more electronegative. What is oxygen general oxidation state? Group number -8. Oxygen is 6th group. 6 minus 8. So -2. Oxygen -2. So each chlorine +1. So 2 chlorines means +2. So because overall is 0, I said, no. So this is about oxidation state of halogen. Next we have to discuss oxidation state of oxygen. Oxygen exists in three types. One is oxide, peroxide and superoxide. Oxidation state of oxygen. Actually, oxygen exists in three ways. One is oxygen as oxide, peroxide, and superoxide. So the three ways how oxygen exists. As I said in previous, oxygen is the 6A group. So what is the general oxidation state? General oxidation state is group number -8. Group number -8. This everybody knows, right? Group number -8. So in oxides, oxygen exhibit this group number -8 oxidation state as oxide. That means 6 minus 8, that means -2. So in oxides, oxygen we represent with O-2. In oxides, oxygen oxidation state is -2. Sir, oxides example means any metal with oxygen, non-metal with oxygen with O-2 charge, like MgO. So magnesium is alkali metal or alkaline earth metal? Alkaline earth metal. So magnesium always +2. I told you already, alkaline earth metals exhibit +2. So that oxygen is -2. I told you in previous, what is that? Total charge will be 0 for a neutral molecule. Said in previous or not? So in that way we can say, so oxide like that. Simply oxides means what? Double bond O or else OH. In this, oxygen oxidation state is -2. Oxygen oxidation state is -2 in double bonded oxygen and like OH. Okay, in OH group, as OH group, oxygen is -2. Okay, so in that way you have to remember. Suppose C double bond O. Double bond O means it's -2. Okay, so like that. Anything else like S double bond O means here -2. OH here double bond O. So -2 here -2 here -2 like that. -2 -2 -2 -2 oxygen here. Got it everyone? So single bond oxygen if you have like this with with hydrogen, and double bond oxygen if you have, oxygen is -2 as oxide. Got it everyone? So next, peroxides. Everybody knows hydrogen peroxide as example, and O2 -2. O2 -2 peroxide. So peroxide we represent in another way also, like this, or else you can represent O single bond O with each oxygen -1 charge. So -1 with this oxygen, -1 for this oxygen, like this. So in peroxides, oxygen oxidation state is what? -1 here. So each oxygen -1 or not? So what you can say in peroxides, you can write in peroxides, oxygen oxidation state will be -1. So in superoxides we will discuss later. First we will finish about this peroxide oxidation state. So here in peroxides, oxygen oxidation state is -1. This is very very important. So some examples if you want, H2O2. Okay, H2O2. So here hydrogen with more electronegative atoms like non-metals. I said you in previous, hydrogen with non-metals, hydrogen +1. Hydrogen with metals, hydrogen have -1 charge. Just previously I was given. So here hydrogen is +1. Otherwise, what oxidation state you want? Oxygen. So let it be X. How many oxygens are there? 2. So 2X. So with non-metals, this hydrogen exhibit +1 I told or not? So 2X plus 2 into +1 is equal to 0. Then 2x equal to -2, x equal to -1. That means here oxygen exists as peroxide. Otherwise, by looking at the molecule, we cannot say are you oxide or peroxide. We cannot ask also. Simply by calculating oxidation state, we can say. Got it, sir, everyone? So oxygen oxidation state, I don't know. That is unknown for me. So that I was considered as X oxidation state. And two oxygens are there. So 2X. And hydrogen is +1. Just from electronegativity values we can say. So please revise electronegativity values once again. I was given one important trick for that. So oxygen is more electronegative. So hydrogen is less electronegative. It's 2.1 and it's 3.5. Oxygen 3.5. Oxygen electronegativity 3.5 electronegativity. Hydrogen 2.1. So hydrogen have less oxidation state. Hydrogen have less electronegativity or not? So hydrogen positive oxidation state. How many hydrogens are there? Close. 2 into +1 is equal to 0. Why you took, sir? Means here this is H2O2, neutral molecule, no charge on it. That's why equal to 0. So 2x equal to -2, then x equal to -1. So H2O2 is peroxide. Peroxide. Why you represented O2 -2, understood? So 2 oxygens are there. Each hydrogen +1 means 2 hydrogens +2. So 2 oxygens will have -2 discharge. So this is O2 -2. This is about peroxide. In the same manner, you can have some more examples like Na2O2. Same story. Here oxygen oxidation state I want. Oxygen I want. So 2x plus sodium is alkali metal. So +1. So 2 into +1. 2 into +1 is equal to 0. Then 2x equal to -2. Then x equal to -1. Like this you can take. Or like many examples. BaO2. Barium peroxide. Barium peroxide. How many oxygens are there? Here 2 oxygens. It's peroxide or oxide, how you said? Sir, means here O2. I will calculate oxidation state. O2. So 2. 2 oxygens. So 2. Oxygen, I am taking oxidation state of oxygen as X. 2x plus. Barium is alkaline earth metal. So 2 is the oxidation state. Alkaline earth metal +2 I said or not? Why I given those points, understood now? To write like this, their oxidation states. I repeat, oxygen oxidation state I am taking as X. 2 oxygens are there, that's why 2x. Barium is alkaline earth metal, so 2. So 2 into now, one barium only there. So +2 is equal to 0. Then 2x equal to -2. Then x equal to -1. So this is barium peroxide. Sir, what is this? Is it oxide or peroxide? Oxide. How you said, sir? See, with barium, how many oxygens are there? 1. So X. Barium is alkaline earth metal. Beryllium, magnesium, calcium, strontium, barium. Barium is alkaline earth metal. 1 barium, so +2. X +2 is equal to 0. No charge on it. So that's why equal to 0. So that X equal to -2. So this is barium oxide and this is barium peroxide. Correct, sir? So in this way we can have about oxide and this is peroxide. Have a look and have a screenshot. And this is an example for oxide and this is an example for oxide. And these are the examples for peroxides. And now I will give you about information. I will give you information about superoxides right now. Okay. So in oxides, what is the oxygen oxidation state? -2. Okay. In what manner it exists mostly? Double bond O and OH. To identify, I am saying, if you know the structure. How to know the structure means we written already. Lewis dot structure and chemical bonding. Got it, sir? So in that way, oxide we know. Peroxide -1 oxidation state for oxygen. For oxygen, what is the oxidation state? In peroxides, -1. How to identify? By calculating oxidation state. And one more important thing is superoxide. Superoxide, third one. So oxide means I was given -2, O -2 and O2 -2, that is peroxide I said. Now O2 minus. See, I'll give you now clarity. This is O2 minus. This is superoxide. That is, what is the meaning? In superoxides, oxygen oxidation state is minus half, minus 1 by 2. Remember all these things. Okay, so how you will come to know the same from examples itself. Okay, so here I will give you some, see, KO2. Whether this is oxide or peroxide or superoxide. Listen carefully. You can easily say by calculating oxidation state. So how many oxygens are there? 2 oxygens. Same story. 2 oxygens means 2. Oxygen oxidation state is unknown. So 2x. X, Y, Z, your choice. A, B, C, D. X I am considering. Here with oxygen who is there? Potassium. Potassium oxidation state is what? +1. Alkali metal means +1 or not? So 1. How many potassiums are there? 1. That's why just I took only 1. I was considered only 1 because 1 potassium is there. If 2 potassiums are there, 2 into +1 I will write. Getting what I am saying? So 2x plus 1 is equal to 0. Then 2x equal to -1. Then x equals to -half. This is what? X is the oxidation state of oxygen. Oxidation state of oxygen. Understood, sir? So KO2 in that oxygen oxidation state is -half. That means KO2 is a superoxide. Its name is potassium superoxide. Got it? I hope you have clarity. So I'll give you the differences between oxide, peroxide and superoxide. Now KO2 is superoxide. This is the example for superoxide. Now let's see. K2O2. Is it peroxide or superoxide or oxide? Okay, see, oxygen exists in 3 types as I said. Oxide, peroxide, superoxide. KO2 is superoxide. I was confirmed because X is -half. In K2O2, what is the oxygen oxidation state? Let's see. So 2x, again same story. So potassiums are how many? So 2 potassiums are there. 2x by taken understood. Oxygen oxidation state is X I am considering. 2 oxygens are there. 2x plus 2 into +1 I am considering here equal to 0. Okay. Why I took 0 understood? So this is neutral. Is there any charge on it? No charge. Why I took only 1 here? +1 I took here because only 1 potassium is there. Why 2 into +1 I taken here? 2 potassiums are there. So 2x equal to -2, then x equal to -1. So therefore this K2O2 is what? Peroxide. Potassium peroxide. Okay. Next K2O. Is it oxide or peroxide or superoxide? Means this K2 is oxide I will say. Sir, why this is oxide? Let's calculate the oxidation state of oxygen. Take it as X, not 2x because here 1 oxygen only there. So X plus how many potassiums are there? 2. 2 into +1 is equal to 0. Then X equal to -2. I have write one more step. X plus 2 0, then X equal to -2. So X is -2. X is what? Oxidation state of oxygen. Here I have written oxidation state of oxygen is X. Here oxidation state of oxygen is -1. Here oxidation state of oxygen is -2. X is the oxidation state of oxygen. In this particular example, oxygen. In this particular example, X is the oxidation state of this oxygen. So here oxygen oxidation state you got -2. Here you got oxygen oxidation state is -1. Here you got oxygen oxidation state is -half. See the differences between superoxide, peroxide and oxide. Okay. So by using these we will write some oxidation states in our next class. And please be careful. I am telling you one more time. Be serious and follow every class and every point to point. And if you have any doubt, okay, without any fear or anything else, you can ask me directly. Personally, you can ask me, you know my number, so you can ask any kind of doubt regarding this class.